I can say now, if I've done the first 4 terms by using n is 1, n is 2, n is 3, n is 4, I need 5 and 6, but I can also say the 100th term. So what I mean by that, do you understand what I mean by a term? Not everything then. So the 100th term is the 100th number in the list, yeah? The 100th, whatever number it will be, that follows the pattern. This one, we know that the pattern is, it goes down by 3 every time, right? Make sense?
Yeah.
So I could start at 1 and subtract 3 and subtract 3 and subtract 3 and subtract 3 until I get to the 100. That's going to be a lot of subtracting 3, right? But we know better than that, don't we? Because we can go straight there and say, right, the T100 or the 100th term is just, the core is starting with 5, and then we subtract 100 lots of 3.
300.
Or 3 times 100, yeah? Because n is 100. This one, yeah? So it would be 5 subtract 300, which is minus
Negative 295.
Good. So the 100th number in the list is negative 295. Because I used this rule, Logan, to work it out. Alright?
No response. He's just like,
Oh, he's thinking. I can see him tapping his head.
he's being, when he does what he thinks.
Alright. That's quite a tricky one though. Alright? At the level that we're at, it's not, you know, it's not too tricky in the long run, but hopefully we're going to get to the point we're using the average size. But if we don't, that's not a problem. We've got them ready. Alright, let's try a simpler one. Right? By the way, this is recording now, so that if you haven't finished your notes, so I know some of you take a bit longer, the video will go on YouTube. You can go home tonight, review it, and write down the notes. You can pause then, can't you, and write down exactly what's there. It's a good way of doing it. Because I don't give you much homework, so this would be a good piece of homework to do, right? Making sure your notes are up to speed. So let's pick a slightly easier one then. So if I said to you, Tn, or the nth term, the sequence is given by the following rule. 5n subtract 2. So what does this rule, what does this pattern go up by? Here?
5.
5s, every time. Goes up. Where does it start from?
2.
It doesn't start from 2 actually. Starts from,
5.
doesn't start from 5. 3, good.
Oh. Oh my God.
2 minus
5 subtract the 2. Because the first term, so I'm going to write it in another way now, slightly different. I'm going to write it in a table looking like this. I've just done this with my M3s. We did a little exercise where we matched coordinates, tables and graphs for linear relationships. And that's important to you because what type of sequences are we doing? What pattern? We're doing linear patterns. Who remembers what linear means? Go on. Goes up by the same amount every time, yeah? Adding on or subtracting. So I'm going to write it not as like the list down that I did. I'm going to write it like a table, and I'm going to say n. All right, here's my little bit of line. Okay, I'm going to say n is 1, 2, 3, 4, 5, 100. Do you remember we did this in a class where you had to write it for each other? And, yeah? So what is the Tn? Well, that's the term. So what is the first term where we would do? T1, or the first term, is 5 lots of, or 1 lot of 5, I should say, that way round. But then you have to subtract 2. And we get the answer?
3.
3. That's what Naomi said, right? And we know it goes up by 5s, because it's 1 lot of 5, 2 lots of 5, 3 lots of 5. So it's 2 lots of 5, but subtract the 2 makes 8. And that's just adding 5. So we just add 5 again, and we get 13, 18,
And then we get
23.
And then we get.
We can't follow this plus 5 now because we want to jump straight to the 100th term. You know how to do it now, right?
Ooh, 77. Yeah, add
The second term.
Add 5.
The second term we could do it's 2 lots of 5. So 5 times 2, 2 lots of 5 is. Then subtract the 2 and I get 8. Or I know it adds 5 on every time because of the 5, yeah? So how do I find the 100th? 100th term, Rocco. So T100.
5 times 100 minus 2 would be
498. Well done. How you feeling, Logan? You ready? You're about staying on your chair? Did that knock you so far back you fell off the chair then? Or are you just struggling to sit in your chair? Both. Have you written that down?
No.
Kieran, what's up? Ryan's like hanging low on his surfboard and he's like, yeah. Alright. But you still find time to pile up the little plastic sticks. Good for that, right? So, here's the next question. Here's the next thing. This is super important. Not playing with the plastic thing. Right. The next thing is, here's the next question. I'm going to use this one again. Are you happy that 3 is the first number, Max? Don't take things too far, Max. Is 3 the first number in this pattern? Yeah? Is 18 the 4th number in this pattern, Jordan? Is 28 the 6th number in the pattern, G? Yes. Why? Okay. So we're happy. The 6th number is just adding 5. Right, I've got a question for you all now. You're just going to try and work this out. So we've just said 3's in it. I've written it. 8 is, 13 is, 28 would be, because if you do 6th term, you would add 5 and get 28. So 28 is. My question is then, is 433 in this pattern? Prove it. Prove it. Right, so this is the kind of question you have to be able to answer. Is 433 in this pattern? Now, I'm not going to accept the answer, yes, because it ends in a 3. Although that might be true, I'm looking for a little bit more. Are you with us, Logan? This is tricky stuff. All I'm asking is if I carried writing this one on, so it goes up to point, we've already gone up to the 100th term, would 433 be in the list, Logan? Stay with me. Sit properly. I'm recording this, by the way, just so you know. All our little, you know. I just want to know, if I were to keep writing them all out, would I write down 433 or not?
Yes.
You might say yes, because it's got a 3 and it follows from 3, 8, 3, 8, 3, 8. But it could be, well, so, the answer is yes or no. What do you all think?
Yes.
Yes. Who's got a reason that's not because it ends in a 3? Emma?
Well, if you notice the pattern, the numbers always end in 3 and 4.
I just said you weren't allowed to say that. Let me ask you a different question. Do you all think it is, yeah?
Yes.
It's the 85th term.
It's the 85th, that's what I was going to ask. What term is it? How can we work that out?
85th. The 85th term.
What do you reckon, Max? How do you know?
Oh,
Because Tristan said it.
Because he worked it out.
Because when you do 5 times 85,
Alright, so this is the important bit, guys. This is where the next phase comes in. Alright, we're not going to be using the algebra tiles now. But this is, we'll do them next time. So those that undid them, you'll have to pack them all away. Right, stay with me. I've still got a couple of minutes, so I want to get this done. So basically, what we're looking to do, Tabby, are you with me? I'm going to write this down. Right, I'm asking, does 5n subtract 2 ever equal 433? That's the question we have to ask. Right? Does 5n, right, this is going to be super important for your assessments coming up. Alright? And we need to know, so you've already packed up, Simone, you're not going to be writing this down, are you? Des?
Yes, because when you like increase pattern like 5, 10, like I don't know what type of number that's called.
I get you.
Increase it by that, it usually ends up following a pattern.
It does, but I want to know, I think Tristan's already done this. Can I figure out what the N is? And this is what we'll do next. I'm not going to do it now because this is going to be too quick. If you know the answer, then you think it's 85, show it. Alright? We'll do this again. N is 85, but I want you to all be able to show this and prove it. There's an important couple of things, alright, to do with your assessments for this bit. Alright?
I don't get it.
No.